In this video, we will determine the domain and range of both discrete and continuous relations using inequality notation. Stop here and grab some graph paper for some of the examples that you're going to need to draw the graphs. I expect the graphs that you draw to be pretty precise, so please make sure and grab graph paper and take the time to do the graphs. Alright, so we're going to go over what discrete and continuous are first. So discrete is a result of counting. We can take only certain values, because if we count on our fingers, that's only numbers like 1, 2, 3, 4. We don't have any values in between those. On the graph, it would look like just independent points from one another. Notice how they're not connected. And that's a way you can remember what discrete is. Discrete is a graph of disconnected points. Some examples for the real world would be like the number of pizzas that we order. We can't order a half a pizza or 3/4 of a pizza. We have to order one whole pizza at a time. Okay, another example would be the number of students in a class. You can't have 22.5 students in a class. So it's based on counting. So a graph of what that would look like would be disconnected, because we wouldn't have any of those points in between. Continuous you can think of as being connected. It will be a result of measuring. And we can take any value within a certain interval. So for example, we could have the line here. Notice how we would have infinitely many points on that line all being connected. So an example of continuous would be the weight of a baby. As the baby grows, the weight will be continuous. There's not going to be a point in time where the baby stops growing and then keeps on growing again. The weight of a baby continuously increases. Okay. We also have the example of height of students. As a student grows, the height is going to be continuously changing. All right. Also, some other vocabulary we're going to need to know is independent and dependent variables. Independent means it can stand alone. It doesn't depend on anything else. So when we look at situations and when we look at graphs, it's going to be the quantity that doesn't need the other one. So x for our situations are always the independent variable. Dependent variable is a quantity that depends on another to determine its value. In any of our situations, the y will always be the dependent variable. Okay, these are problems where I want you to find the domain and range of discrete relations. These are discrete because we don't have any values in between. It's just disconnected points. So I have a mapping here, and I want you guys to determine the domain and range. Make sure to use those set domain notation. We have a table here. Once again, use that set notation for the domain and range, and then domain and range from a graph. Please make sure and put this graph on graph paper and plot those points that you see. For the continuous functions, right now what I want you to do is I want you to copy all of the graphs down, and then in class tomorrow we're going to go over the inequality notation that I want you guys to use. So right now I want you just to make sure and have these down, and we're actually going to talk about the domain and range of these in class. So you have these two examples. Make sure and pause here so that you can graph these relations. We have these two relations as well, so pause here so that you can copy those graphs. And then you have these two relations here. Make sure you're plotting those exact graphs. So notice the points, the exact points that you have on each of those graphs so that you can get those points exact.